Yeah. First, I will ask from Suma. So, Suma Lata Bolgam. Okay. Please tell me about yourself.
Good evening, sir, and thank you for providing this opportunity. And myself, I'm Sumlata, and I have completed my master's in VLSI from Indore Institute of Technology. And after that, I worked in DRDO as a quality assurance engineer, sir. And to acquire knowledge in VLSI, recently I have completed my physical design training from Siemens Private Limited. And tools which I have used is for synthesis Genus and Innovus for PNR. And I have done 4 projects. One is full chip level and remaining 3 are block level. And technology I worked for is 190 nanometer technology and 45 nanometer technology. And I have learned how to do floor planning, power planning, placement, and CTS routing. Thank you, sir.
Okay. And Venkatsakolur. Okay, please introduce yourself.
Myself, Venkatesh from TKR College. I didn't did any project regarding physical design, just theory part completed.
Okay. And have you done any project in anywhere, like in any project you have completed in your BTech or Masters? Okay.
Not yet.
And your relevant coursework which you have completed during your preparation or during your BTech?
I am from easy background, sir. I did a project like software IT field like that.
Okay. So which project you have done in your graduation?
Detection of non-helmet rider and extraction of license plate.
Okay. So which
internship also like medical system, based on medical system, I did an internship 2 months.
Okay. So Sunlata, are you comfortable in digital electronics?
Yes, sir. No problem. But I'm looking mainly in physical design, sir. Actually, I have to.
Okay. In physical design. So could you explain me the working of NMOS transistor?
NMOS transistor, sir.
Yeah.
In NMOS transistor, majority carriers are electrons, sir.
Okay.
VDD is connected to drain, sir, and VSS is connected to source, sir, in NMOS N channel MOSFET. And
first tell me that how the electron will flow from drain to source, like.
Sir, it's the main principle is mass capacitor principle, sir. And when we are applying the voltage at the gate, due to mass capacitor, channel will be formed, sir. So based on that, voltage will passes from source to drain, sir.
Okay. So did you know about the depletion layer, like channel which form?
Yes, sir. In the depletion mode MOSFET, already channel will be present, sir.
Okay.
In the enhancement mode, channel won't be there, sir.
Okay, actually we have 3, like depletion mode, accumulation mode, and inversion mode. So in which mode we are using NMOS as a, like in our application in CMOS?
Enhancement mode only we use, sir. We use enhancement mode because
actually we are using enhanced mode metal oxide FeLSFET transistor.
Yes, sir.
So this transistor, that MOS capacitor is actually some noise is coming from some side.
Sir, my end, no one is there, sir. From
Venkatesh, could you Please, could you mute your mic for sometimes? I will let you know when I will start. We will start from you. When we're okay, 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 okay. Now it's okay. So actually, in MOS, when we apply when we apply different gate voltages, then it will go to in accumulation mode and depletion mode. After that, inversion mode. Okay. So which mode we will use for complementary CMOS?
Complementary CMOS, we use enhancement mode only, sir. Actually, the difference I couldn't. I have to go through it, sir. But I'm not able to understand the question, sir.
Okay, 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 no issue. So, did you know about the noise margin?
Yes, sir. Noise margin.
Okay, what is this?
Sir, if any design it has to work, noise margin should be maximum, sir. So limit should be maximum, and it has to withstand up to that noise, sir. Noise margin. Any system when we are designing, it should be withstand up to that noise margin, sir.
It's a general definition. It don't sound like you are giving any technical answer.
Okay.
Yeah.
I'll go through it, sir.
Okay, okay. So basically, you have okay. Tell me about the ASIC design flow.
Sir, mainly design specifications, sir, and after design specifications and architecture will come, sir, and after architecture RTL code, sir. From RTL verification, from RTL verification and synthesis, from synthesis gate level netlist, from gate level netlist sanity checks. After sanity checks, we do floor planning, power planning, CTS, routing, and
Okay.
next physical verification, STA, physical verification, and final outcome of chip, sir.
Okay, why do we have different clocks? What is the need of different clocks? Why we do clock tree synthesis?
Yes, sir. In clock tree synthesis, we need to propagate clocks to each flop, sir, by maintaining minimum skew and minimum insertion delay, sir, to avoid setup and hold violations.
Okay, okay, we will do like that. Okay, let's suppose we have if we have two IPs. Okay, we have two flip flop. Like I'm not saying IP. Actually, I'm saying that we have two flip flop. One flip flop is operating at clock frequency 1, and second is operating at clock frequency 2. So
Yes,
these two IPs, like these two flip flop, have different clock frequencies. Then how they will communicate?
Okay.
Yeah.
Different clock frequencies.
Yeah.
One is from launching flop, we need to launch the data, sir, and the second one is the capturing the flop, which is whatever the flop is there. From that, we need to capture the data, sir.
Yeah, it's okay. It's a basic difference means definition of setup and hold time. And I'm asking that if there are two types of clock, like one is with clock frequency 1, and second is
One, yes, sir.
clock frequency 2, then they will need to communicate at different clock. Then what is your approach to solve this problem that I have two different clocks and two flip flops which operate at different frequency? Then how can you resolve this issue?
Okay. No, sir, I have to go through it, sir.
Okay. Just write down where are you sticking. Just I'm not where you are sticking. Okay. So you write take some time and you write where are you not comfortable. Then I will come to you and let me talk. ask to
Okay, sir.
Venkatesh. Okay.
Okay.
Venkatesh, are you there?
Yes, sir.
Okay. So could you please switch on your camera? Okay. So have you gone through the digital electronics?
Yes, sir.
Yeah. So could you tell me about how can I get a frequency f by 2 if my required frequency is f by 2 and I have the frequency f? Then which electronics, which circuit I have to use so that I can get the frequency of f by 2? Just draw that circuit
Can you
diagram.
repeat again, sir?
Actually, let's suppose I have a clock frequency f. Okay, then I have one IP. I have one flip-flop which needs to operate at frequency f by 2. Like I have some circuit which have to operate at frequency f by 2. Then how can I get a frequency f by 2 from f? Which circuit you are going to use and how can you get frequency f by 2 from f?
I don't know, sir.
You don't know. Actually, you never gone through like a counter, like
Yes, sir, I know counters like that, but I don't know that concept like f by 2 like that.
okay, you don't know the one. So, did you know about like a sequential and combinational circuit?
Yes, sir.
Okay, so
In the
please tell me about the difference between sequential and combinational circuits.
in the combinational circuit, inputs depends upon the output depends upon the combination of the inputs present input. In the sequential circuit, output will depend upon the present input and past output, sir. In the combinational circuit, memory element does not consist. In the sequencer, it consists of memory element.
Okay. And other than that? Do you think the only 2 points are sufficient to impress the interviewer?
No, but
so I'm asking very simple questions. So please at least try to tell 2-3 means more than 2 points, like 3 to 5.
Okay, combinational circuit faster, sequential circuit slow, sir.
How?
Because it depends upon past outputs also, sir. That's why I think.
Okay. So, could you make a mod 8 counter?
Mod 8 counter.
Yeah. Take a pen paper and try to make a mod 8 counter. I will come back to you. Okay. Hello, Suma. Are you there?
Yes, sir.
Okay. So, did you write where are you not comfortable in those particular area? Could you written down this? Have you written?
Yes, sir. Mainly in CTS, sir, and whereas in placement, sir, how to in PD, sir, in physical design, mainly in placement stage as well as in CTS stage, sir.
Okay. So do you know about the what other subjects you have covered? Are you yeah.
Means, sir, about CMA, sir, and mainly I'm concentrating on physical design, sir.
Okay. In physical design. Okay. So, do you know how to make how we generate the different voltages? Actually, when we are planning the layout, of any IP, then if each and some component used to voltage 2.5 and some needs 1.2 and some needs 0.8. Then how can we generate different voltage and which circuit we have used? If you know about them, then please let me know.
No, sir, I'm not aware of it, sir.
You don't have a report. So what is your basically work you have covered till now? Like
Floor planning, sir, mainly synthesis and floor planning, power planning, placement.
okay. So you have know about the idea about low power design. Did you have the idea about low power design? Like
No, sir.
how can we save the power?
Power to save the power, we need to size of the cell need to be reduced, sir. Means drive strength. We can reduce the drive strength and the clock gatings we can use, sir.
What is the clock gating?
Clock gating, clock is a high switching clocks or high switching net, sir. Any unwanted if any unwanted net, if it doesn't need a clock, it acts as a gate, sir, and to avoid clock propagation, we use clock gating, sir.
Okay, could you make the circuit of clock gating?
Sure, sir.
Okay, please make. Venkatesh, did you able to draw this?
Sir, I'll take my
Yes,
pen.
right, sir.
Okay. Take your pen and paper and.
Okay.
Yeah. Yes. Okay.
Are visible?
Yeah, it is visible. Okay. If Venkatesh, if we want mod 6 counter from that mod 8 counter, then what are extra circuitry we have to use, and from where we will take input, and and how we use the output of that circuitry. From this circuit, if we want to implement mod 6 counter, then what are the changes we have to make in this circuit?
Mod 6 counter.
Yeah, mod 6 counter.
No, it is.
Okay. So for which profile are you are targeting, Venkatesh?
PD profiles.
Okay, PD profile. So you have idea about like clock gating and clock resynthesis, PNR, and what
Yes,
do you know?
I know PNR and SCA. I know digital electronics like flip-flop latches, like that. Basics I know.
Okay. So okay. So tell me that how can we save the power in physical designing? What your approach to save the power?
Uh,
Yeah.
we will reduce area.
Okay then.
We will minimize like wiring
So how
routing.
what yeah, routing, then what is your approach, means what are technique you have used to save the power?
like like what?
Means how can you save the power during physical designing, during the layout?
Uh, I think
Okay, do one thing. Uh, Venkatesh, do one thing. Please write down the topic where are you not able to answer, so that use those points as a feedback and and prepare later. Okay, just write down those points. Hello, Soma. Did you get the
Yes, sir.
able to draw? Okay, just show me.
This, sir, negative triggered flop and one AND gate, sir.
Okay, okay.
And one more thing, sir, to save power, HVT cells we can use, sir.
HVT.
For
Which?
time critical path, we use LVT, sir, but
Okay.
for power saving, we can use HVT cells, sir.
Okay, okay. Do you why are you we are using gray code instead of binary sequential binary code? Why we use gray code? There is some link between the power saving. I give you a hint and please try to find the answer.
Okay, sir. Okay, sir.
Yeah, yeah. Venkatesh, did you
Sir.
wrote down those points?
no, sir. But I can tell you.
Okay, okay, no issue. Just remember. So, did you know about how we make how we do if we need different clocks, then what is your approach to provide the different clocks to different IPs submodules?
Uh, in that case, we will use CTS now, sir.
Yeah, so what type of CTS, and could you please explain something so that I can know what is your answer. CTS is just you are means answering the name of a topic.
Yes, sir. I mean, CTS means we are balancing the load. Like we are firstly we will give a clock to the all micro standard cell, no standard cells like this. So after that we will balancing the load by giving buffers and inverters.
Okay, okay. So, did you know how we generate the clock?
No ideas.
No idea, no idea. Okay, okay. And okay, okay. So, uh, just tell me about if we connect two inverter back to back. Okay.
Okay.
So this is the very basic element of storing. Just draw two inverter back and tell me how they will store the data. Okay.
Uh, if A is the data, it will get output as A is.
Okay, so why we are not using like these two back-to-back inverter, and we are using some other devices one inverter is. Did you please draw inverter, CMOS inverter in your copy?
CMOS in.
Yeah, Suma also
Okay.
you have to draw a CMOS inverter.
Okay, sir.
Did you find the answer of gray code, like why we are using gray code?
No, sir.
Okay, 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 okay. Draw a CMOS inverter. Okay. So connect one more CMOS inverter to the output
Okay.
as output as input. Okay, connect it.
Can you repeat, sir?
Connect one more.
Okay.
Okay. Okay. So Suma, you have no. Okay. So why we are and connect the output of second inverter to the input to the first inverter. Okay. So just if I provide input as a 1, okay,
Okay, sir.
okay, just a pulse for very small duration, okay, then
Okay, sir.
then output from the first CMOS is 0, and output from the second CMOS is 1. So it will become like a memory element, okay.
Okay, sir.
So here we are using 4 transistor, okay. So why we are using 6 transistor instead of 4 transistor? In for practical purpose, we are using 6 transistor, 60 SRAM cell instead of these 40 cell. Did you get my answer question?
No, sir. Can you repeat it, sir?
Okay. I'm saying just connect back to back, like output of second CMOS is connected to the input to the first CMOS.
Yes, sir.
Okay,
Yes, sir.
and output of first CMOS connect to the input to the second CMOS. Okay. So
Okay, sir.
just tell me that we are using 6 transistor, a 4 transistor here. Okay.
Yes, sir.
If we give impulse per pulse, initially we give one impulse per pulse, then it will store 1. Okay.
Okay, sir.
Okay, store 1. So it will act like a memory element. Okay.
Yes, sir.
And why we are not using these 4 transistor as a memory element? Why we are using 6 transistor?
If you use 4 transistor, it will become complementary now, sir.
Complementary CMOS will become if we are using 2 transistor, it will become complementary CMOS. Did you know what is the question?
Sir, you are asking why for storage, memory storage, why we are using only 4 transistors instead of 6, sir?
No. Why we are using 6 transistor in industry instead of 4 transistor? Even though 4 transistor can store the bit.
Okay, sir.
Yeah. Yeah.
Okay. For delay purpose.
Sir, power consumption will be more, sir, when both are connected in series, no, sir. So power consumption will be more, sir.
Okay, and whether this is not appropriate answer.
Okay, sir.
Okay.
I think for delay purpose.
No, delay is also not the part of it. Okay. So, and okay. So, did you know about the body bias effect?
No, sir.
Actually, in physical design, you should know about the body bias effect, short channel effect. What is the short channel effect? Actually, these things are required in physical design, I think.
Sir, short channel effect means that pinch off only, sir.
No. Actually, we have formed a channel between drain and source.
Yes, sir.
Okay, if we reduce the size of this channel, okay, like you said that I have work on 90 meter,
90 nanometer.
90 nanometer.
Yes,
so
sir.
so the length of channel is 90 nanometer.
Yes, sir.
Okay, this channel length is 90 nanometer. If we reduce the size of channel, then what effect will have, which it will feel. Okay, so that comes under the short channel effects.
Okay.
So I want to know what is the short channel and what are the consequences of short channel.
Sir, if the
Why?
channel length be decreases, the current flow will be reduces, sir.
How if channel is small, then how it will going to affect the channel current?
It act as a bridge, no, sir, from source to drain.
Yeah.
So if the channel is if the channel okay, channel length, not the thickness. Okay, sir.
Yeah.
W/L.
Venkatesh, did you know that what is happened when we are?
Sorry, the voice is not clear.
Okay. Actually, this is problem from your end. Okay,
Hello.
just listen. That I'm saying that if we reduce the channel size, then what happened to the circuit CMOS, and what effect it will appear? What effect will be appear after the short channel effect? Hello.
Hello, sir. Sir, your voice is not clear.
Suma, my voice is clear?
Yes, sir. For me, it is clear, sir.
Sir, now it is
Actually,
clear.
okay, that's clear now. So I'm saying, did you know about the short channel effect? Like what is the short channel and what are the effects of short channel?
I don't know. No idea.
Sir, actually, if the length be decreased, there won't be any connection between a source to drain, no, sir. If the length be decrease, means it.
I'm not saying that we are connecting source to drain. I'm just decreasing the length of that channel. Okay. If I'm decreasing the length of that channel, then what are the consequences and what effect it will appear? Effects are appear on that CMOS and the electrical properties of the CMOS. Okay, let me go through a very basic thing. Just tell me what is the resistance. Okay, Venkatesh, please tell me what is the resistance and what is the resistance. Okay, very basic question from 12th standard.
Okay, it is opposes the flow of current, sir.
Opposes the flow of current. Okay, So you are saying that I have a wire like a resistor. If I am giving a 4 ampere current as input, then it will provide me 3 ampere of current. Like it opposes the current. Like that.
Based on voltage. If you provide a 2 voltage for the resistor,
Yeah.
consider
No, I'm saying that you are saying that it will oppose the flow of current. Okay, so I have a resistor in which have two nodes like A and B. Okay, if I'm providing the 4 ampere current at node A, then node B will going to give me the current less than 4 ampere.
Yes, of course.
So have you ever seen anything like if the you don't know about the conservation of ampere law, like we have two laws, current
Sir,
from current at input
sir,
node is
if based on resistor serial or parallel like that, we will
actually I mentioned I have only one resistor, no, not serial.
okay, 4 amperes.
So earlier you are saying that it is going to resist the oppose the flow of current. Then you didn't find any resistance in flow of current. Then what is the resistance? So your basic definition, you are saying that the resistor is something which opposes the flow of current. So it is not opposing the flow of current. The current which is entering and current which is coming out is same. So how can it resist the flow of current? Did you get my answer now? What I am
Yes,
asking?
sir. Yes, sir. I understand.
Yeah, I'm not asking a rocket science. Very basic question from 8th standard. Okay, Sumna, tell me what is the resistance?
Sir, actually resistor means which oppose the current, sir, but resistance it's a measure, sir. Means in it measures in ohms, sir.
Okay. So what resistor does? Why we are using resistors?
Why we are use resistors?
What is does? What is its functionality? What is does like oppose the current and oppose the restore the charges and produce electromagnetic field? What is does?
Okay. Sir, if any if any device it should not get damaged, sir. So to oppose the current flow, we use resistors, sir.
Okay, to oppose the current flow, we use the resistor. Let's suppose I have a resistor. Okay, 4 kilo ohm.
Okay, sir.
Okay. Okay, and I have a make a circuit like I have a resistor 4 kilo ohm, and the current and the voltage which is I'm going to apply the both positive and negative terminal of resistor.
Okay, sir.
It is 4 volt.
Okay, sir.
Then
Okay,
current flowing through the resistor is 1 ampere.
1
milliampere.
One.
1 milliampere.
Yes, sir. 1 kilo ohm means yes, 1 milliamp.
Okay, 1 milliampere. So the entering current at resistor is 1 milliampere. The outgoing current through the resistor is 1 milliampere. Then how can it oppose the current flow of current?
We could tie or
Venkatesh, could you find any answer which is right according to you? Actually, you understand the question what I am asking.
Yes, sir.
Yeah.
Regulates the flow of current.
So it is not like current is not reducing. Then how can we say that it opposes the flow of current?
Sir, we generally say V equal to IR, no, sir. In that case, generally we say R is directly proportional to voltage and inversely proportional to current. Like that. After
Okay,
that,
okay, okay. Leave it. I come to a second question. What is Ohm's law?
okay. Ohm's law, voltage directly proportional to V equal to IR, sir.
IR, sir.
I equal to
Okay,
V by R.
okay, okay. Just draw the basic circuit diagram of Ohm's law. Suma, did you get any answer that what is the resistance?
Sir, actually, it's a sir, V by I, sir. Actually, it's a ratio of voltage and current passing through any net.
So from your basic idea, you are saying that resistor is opposes the current. So did you find like a minute change like 0.001 milliampere is going to change? Means it reduces at this amount.
For
Na?
longer nets, drop will be there, sir. For longer nets, there will be some drop will be there, IR drop.
IR drop. Did you know IR means voltage drop? I
Yes,
into
sir.
R
I
means
into R means, yes, sir.
voltage drop, not
Yes.
the drop in current. Then there is no drop of current. Then why are you guys saying like that? It opposes the flow of current.
Sir, in generally what we learned in our
Okay, okay.
academy, that's the same thing
Okay,
we are
okay.
conveying, sir. Actually, but
Okay, actually,
we'll go through it, sir. We'll go through it, sir.
yeah,
What
yeah. Okay, just tell me what is the Ohm's law?
Sir, V is equal to IR, sir. Voltage is directly proportional to the current, sir.
Okay, well, it is directly proportional to current. Okay, just draw a circuit diagram of that Ohm's law. Want to check.
Sir.
Okay. Just change the voltage. You are using voltage as a source. So take the current as a source. Okay.
Okay, sir.
And now is Ohm's law applicable or not? You said that V is equal to IR. Then how now it is applicable or not? Ohm's law is applicable or not?
No, sir.
Now Ohm's law is not applicable. Venkatesh, could you able to draw the basic circuit diagram of Ohm's law?
Yes, sir.
Okay, just
But
please.
I think
Actually, yeah, it is not visible to me. Yeah, I can see. Okay. If I change the voltage which are you using as a source with current source, then Ohm's law is applicable or not?
sir, not applicable, sir. We place a resistor in parallel.
Well, so place resistor in parallel, then tell me that it is applicable or not.
Yes, if we place a resistor in parallel,
Parallel with whom?
with the current.
So to make a circuit, na? Then show me then how we are going to place the resistor in parallel to the current. Okay, so why you are attaching a voltage source? I'm not saying that you have to use the voltage source. Remove the voltage source, then I'm asking, it is ohms law is applicable or not?
No, not applicable, sir.
Okay, okay. What is your opinion, Suma?
No, sir.
Not applicable. Okay, it's okay. No, it's okay. So as I can see, it is approx 45 minutes. So I want to tell you guys, like, please go through the basics. Okay,
Okay,
like, okay, and after the basic, and be focused on the basics only. Okay, interviewer is not asking a very tough question, and do some small projects. And any interviewer are going to appear like, whatever you are desired to, like physical design or something, just go through the basics, and after that complete the digital electronics. Every interviewer asks you the question from the digital electronics. Okay, and as you are interested in physical design, so you should know about CMOS, what is the CMOS and MOS and noise margin, short channel effect. These basic things you should know. And other than that, there are also some topics like, what is the static timing analysis, whole concept you have to cover. That after that, clock, like clock domain crossing, and do some projects. And after that, you should know where you are going to apply your job. Like physical designing is your domain of interest, so you should have very clear cut and crystal clear concept in that particular thing. Okay, and you should know the whole process, like how a chip is manufactured. Customer is giving the specification that I need the chip and IP or module which have this particular specification. Then it use the knowledge of the architecture, and draw the, like layout, means like a draw the out block diagram at that I have needed this. Then they will start using the digital electronics and write the RTL code. You should know each and every step, then how the process is going from RTL to GTS. Okay, and after that you should know some basics of C programming. Okay, actually, and other than that, if you know some operating system like Linux, actually every company is using the Linux operating system. Actually, it has some advantage. Okay, so these things is also required for you. And after that, and very have crystal clear concept like clock switch synthesis, PNR, and how to draw the layout, power management, and the step which are required in physical design. Okay, these are required, and do hard work for it. Okay, and stick to the basic. Start from the basic. Don't be in hurry that I can cover whole things in 1 month. Take 2 3 months. 2 3 months is enough. In 2 3 months you are in a good position, and you can give an interview at any company. You can easily crack it. Okay, and don't be in hurry, and don't try to capture all the things in over and one night. Just read and practice something, and after that take time to think about it. 5 to 10 minutes, then what I have studied, and what I'm understand, and can I explain this thing to other. Okay, this is the thing which you adopt from this. I want you guys to adopt. Actually, whatever you study, it is useless until and unless you are not able to tell to the interviewer. If you are not able to answer those things to the interviewer, then it is useless for you. Till that you are not going to get a job. Okay. Okay.
okay, sir. Okay, sir.
Okay. Okay. This is from my side. And other than that, if you have any question from me, then please ask.
Sir, different clocks for 2 flops. That question is there, no, sir? Can you tell me the?
Okay. For that, we are using like we are using flip flop. Okay, SR flip flop, D flip flop, T flip flop, toggle flip flop. So we are giving the clock like a frequency with F1. Then output will produce like frequency F by 2.
Okay.
Okay, just go through that digital electronics. That's why I'm mentioning that you have to study the digital electronics. It will give the whole idea. Okay. And other than that, any question if you have, please tell me.
Answer that last question, sir.
Which?
Ohm's law. We replace current with voltage.
That's why I'm saying that you have to go through the very basic questions. Okay. Actually, the in our curriculum, like in our schooling, every teacher told us that we have a voltage source, and if we can attach a resistor, okay, after means you have voltage as a source, okay, and that's why you are having different equation for a voltage source, and if we are using the current as a source, then we are having other equation. Okay, it means you are going to, like, we have y is equal to mx. Okay, just listen to me very carefully. We have y is equal to mx. Y is dependent variable and x is independent variable. Like we have the values of x, different value of x, like x is equal to 1, then x is equal to 2, then x is equal to 3. Then we can able to trace the diagram, trace the straight line. Okay. Okay, so here x is the independent variable and y is dependent variable. Okay, so in Ohm's law, if we are having the, like we are having the voltage, so voltage is independent variable and I is independent variable, a dependent variable of v. So here equation is I is equal to 1 upon r into v.
Yes, sir.
Okay, so this is for when V is as a voltage source. If I as a I as a use, we are using I as a source. Okay, then equation is equal to V is equal to IR. So it is basic things which interviewer know that here you can, means you are not able to answer. So please means be clear with your basics and go from the like basic thing. Just go and see that why we are using capacitor, why we are using resistance, and what are the current and what is the voltage. Very basic thing. Then come to the CMOS and know the NMOS and PMOS, the noise margin, then short channel effect, some definition, body wise effect and all. And after that come to the digital electronics, then cover the digital electronics, whole digital electronics. Then after that, whatever your specialization you want, you can jump into that. Okay, no
Okay, sir.
other you need. Okay, any other question if you guys have to, then I will take those questions, then otherwise we have to leave.
Sir, you asked
Yeah.
that we are using clocks in CTS. Explain that answer.
Okay, clock. So
Yes, sir.
like in one IP we have like you know that guys that CPU is very fast and it operates very fast speed, and other than we have like GPIOs, general purpose input output, like keyboard and mouse, those speeds are very less. So the our CPU require very high speed. Okay, operated at very high speed, so it requires the clock frequency at very high speed, and our other general purpose IPs like keyboard and mouse require very like operate at very low frequency. Okay, so in that way we require like different clock frequencies. So that's why we are using clock tree synthesis. So we will differentiate the different we are using different clock, and we are generating different clocks. Okay, so that's why there is a concept like different for different generating different clock. We have also have a clock tree synthesis is different, like how can you provide clock to the nearest IP so that the clock is not reducing its operating frequency. So this is related to clock tree synthesis. We have H diagram, T diagram, star diagram, and different diagram to operate, means to so that we are get the clock operating frequency at optimal speed, and it should not degrade the performance and speed of the clock. Okay, so also we have like a different clock IP, so that's why we are using different clocks. And for getting the different clocks, we are using circuit, and if basically the circuit cycle we are using the counter circuits. And other than that, if you have any questions, so I will take, otherwise
No,
Okay.
sir. From my end, no, sir.
Yeah. Okay, so guys, it's okay, and please go start from the basic. Don't need to be in a hurry. And if you have any question, then just ping to the Rajat, and I will take those questions. Okay.
Okay, sir. Thank you, sir.
You are welcome.
Okay,
Bye.
thank you, sir.
Bye. Bye. Good night.
Bye, sir. Good night, sir.